Okay, hi, this is Mrs. Myers again. This is our second video for the Unit 1, Lesson 3, Introduction to Proofs notes. If you remember, we did all of this on the first video. We went through all of this. I actually have made a couple of revisions to the notes, so you may have been watching that video and noticed that there's a couple of things that were different. So I just want to address those now. First of all, these two statements are going to be important about substitution property. When we get into doing more proofs, you will probably hear me repeat this many times. So let's just look at it. First of all, substitution property can only be used with equations. So you always have to have that equal sign. If you're going to use substitution property, you are only substituting into an equation. One thing is equal to another thing, so it can be used to replace that thing in an equation. You're never going to substitute into a sentence. You're never going to substitute into anything but an equation. Okay, so that's the first thing. Second thing, we're going to see an example of this later. If two expressions are equal to the same number, then you set the two expressions equal to each other by substitution. We're going to see an example of that in a little bit. Now, I mentioned on the first video that eventually we were going to be taking the vertical angles concept and turning it into a theorem. And so your notes were a little bit different than that video. So here it is, the vertical angles theorem. Vertical angles theorem says if two angles are vertical angles, then they are congruent. So we have this word congruent. Now, I know you've heard the word congruent before, you've used it. So officially we're going to define congruent angles as angles that have equal measures. So in other words, if two angles are congruent, then their measures are equal. I might write that this way. Let's say if angle 1 is congruent to angle 2, then the measure of angle 1 equals the measure of angle 2. So you probably want to add that little note in there because that is really how we're going to be using it in a proof. When you have angle 1 congruent to angle 2, for example, your next statement can be the measure of angle 1 equals the measure of angle 2 because of this definition of congruent angles. Okay, so we did this proof in the last video. Actually, it's changed a little bit now, so let's do it again. We're given that measure of angle 1 equals x, and measure of angle 3 equals 56. So x 56 is the basic proof here. So notice the difference between the last video and this video. This second step says we're going to use vertical angles theorem. So it's the theorem right here that says the angles are congruent. We're not going to say they're equal anymore. First we're going to say they're congruent. So you're going to say angle 1 is congruent to angle 3 by the vertical angles theorem, because we can see in our diagram that our angles are vertical angles. And so we're going to just say they're congruent by the vertical angles theorem. You might see sometimes people have an additional step like in between here that says angle 1 and angle 3 are vertical angles by the definition of vertical angles. We mentioned that in the last video. I'm going to move away from that step. I don't think it's necessary. So you can go straight to saying angle 1 is congruent to angle 3 by the vertical angles theorem. I want you to notice one thing here. When we're using this congruent sign, we're saying angles are congruent. There is no little m when you're using a congruent sign. No little m when you're using a congruent sign. The measures are equal because they're congruent, but when we're saying they're congruent, we just say angle is congruent to angle. Okay? Our next step, though, is necessary to turn that congruent statement into an equation. The measure of angle 1 equals the measure of angle 3. Since they were congruent here, that makes them equal here. That is always going to be a really common combination, just like we talked about common combinations in the other video. And our reason there is definition of congruent angles. Measures are equal because they're congruent. These actually could be turned around in another proof where you have the measures equal and therefore you say they're congruent, and that's also definition of congruent angles. Okay, now we are ready for substitution. Notice we want to prove that x equals 56. Right now we have measure of angle 1 on the left of our equal sign. And we can see here that measure of angle 1 equals x. Well, if measure of angle 1 equals x, that means by substitution, wherever there's a measure of angle 1, I could replace it with an x. So there's a measure of angle 1, I'm going to replace it with an x. On the other side of our equal sign, we have the measure of angle 3. Measure of angle 3, and we know that is equal to 56. So wherever there's a measure of angle 3, I could put a 56. So I'm going to kick out this 3 and put a 56. So we substituted. That is going to be substitution property. Now, remember what I said about substitution. It can only be used in equations. So that's why it was so important here to move this congruent sign to change that into an equal sign. Because if it stays a congruent sign, you're not ready for substitution yet. You have to change it to an equal sign in order to use substitution. It has to be in equations. Okay. Let's move on. We have another kind of proof called flowchart proofs. This is just the same idea as the two-column proofs, but we're going to show our logic in more of a visual way. You can refer back to this after I show you some flowchart proofs, but I'm going to go straight into giving some examples. So look at this. This is more of a visual instead of the two columns. Same proof. This is the same proof as we just did. Flowchart proofs, what you want to do is put your given, write it down, and put a box around it. Now, instead of another column where we put our reason, we're going to put our reason right underneath. Every given gets its own box. So that's a given also. There's only two givens, so that we start with those two boxes. Now, what you want to do, kind of over here by the diagram, is relate those givens in some way by looking at the diagram. And this is where we can say, aha, 1 and 3 are vertical angles. So right here you can say angle 1 is congruent to angle 3 by the vertical angles theorem. Sometimes that's abbreviated VAT. Now, notice these arrows. These arrows are literally saying this statement in this box leads me to conclude that, so this statement in this box says angle 1 is congruent to angle 3. That leads me to conclude that the measure of angle 1 equals the measure of angle 3. How did I conclude that? Because I know the definition of congruent. Means that if two angles are definition of congruent angles. It means that if two angles are congruent, that makes their measures equal. Now, notice this box. This box has 3 arrows coming to it. 1, 2, 3. Why 3 arrows? Because this box is going to take that information from all 3 places. Measure of angle 1 is x, measure of angle 3 is 56, and 1 equals 3. And we're going to substitute. So in this box, we're going to write x equals 56. That's using this information, that 1 equals 3, and at the same time substituting x in for the measure of angle 1 and 56 in for the measure of angle 3. So that was using all 3 of those boxes. Information was needed for this statement. And that's all through substitution. Okay, so let's do a few more to practice. Remember, substitution is only used in equations. That's why we had to make our congruence into equals. All right, so number 9. This one, if we look at our diagram, we can see we're dealing with a, hopefully you're all thinking, linear pair here. Here's our givens. So every given gets its own box. So measure of angle AOM equals 2x plus 30, and the measure of angle MOC equals x. Those are our givens. Now over here, in the separate box, we're going to kind of make a conclusion from this diagram. We can see that those two angles that they've given us are a linear pair. And we know that with the linear pair postulate, the linear pair postulate says that if two angles are a linear pair, then they're supplementary. So I'm going to use that information and say angle AOM and angle MOC, those are the two angles they give us, are supplementary by the linear pair postulate. Linear pair postulate says they're supplementary. Remember, this arrow now means from that fact, what can we conclude? Well, if angle AOM and angle MOC are supplementary, that must mean the measure of angle AOM plus the measure of angle MOC equals 180. Reason? That's by the definition of supplementary. We read that fact and we say, oh, they're supplementary, that means they add up to 180. Okay, now again we're going to use these 3 boxes. 1, 2, 3. They're all pointing to this box because I'm going to use this equation that I wrote, this general equation, and I'm going to substitute into it. Measure of angle AOM is 2x plus 30. So in my new box, I'm going to substitute 2x plus 30 where the AOM was in this equation. Measure of angle MOC is x. So I'm going to replace MOC with x. Equals 180, so that's going to stay equals 180. And that was by substitution. Kicked out one expression and put in another. That was equal to it. Notice whenever you're using substitution, you have to have an equation you're substituting into, and then you have to have arrows coming from the boxes where there was a statement saying these two things are equal. That makes them substitutable. Okay, from here it's just algebra. What are we going to do here? We're going to add 2x and x and get 3x plus 30 equals 180. And what did I do? I combined like terms. My next step, I'm going to subtract 30 from both sides. My result is going to be 3x equals 150 by subtraction. And that's a property of equality. And then I'm going to divide by 3 on both sides, and I'm going to get x equals 50, and that's by the division property of equality. All right, let's go on and look at a couple of more examples. This is that same proof, but in 2-column form. So I'm going to have you pause the video and do this on your own, and then turn the video back on to check your answer. Okay, so you can see that the same exact steps that we had in all of our flowchart boxes are represented here, and the reasons, all the reasons are represented here as well. I'm just noticing this numbering is off. Okay, So let's move on. Number 10 is another example of a flowchart proof. Here, kind of letting you on your own to try this one and set it up yourself. If we look at our diagram, we can see it's not a linear pair, it's not vertical angles. So this is going to be an example of angle addition postulate. We've got two angles next to each other, and they make up one big angle. So if we look at our given, measure of angle 8 is 14x minus 12, and measure of angle 9 is 4x plus 4, and the whole angle is 17x minus 1. It's angle ABC, 17x minus 1. So again, we put our givens in the boxes. I'm going to let you do that yourself, and I'll help you with this relationship. There's going to be a box over here under the diagram. The relationship we're looking for here is the measure of angle 8 plus the measure of angle 9 equals the measure of angle ABC. This is how we state the angle addition postulate. It's always going to be a statement of one little angle next to another little angle, add up to be the whole angle. Notice there's no angle measures in here. You're not saying 32 degrees or 180 degrees or 57 degrees, anything like that. We're actually naming the angles for what they're called, not how many degrees they are. Okay, so this is the measure of angle 8 plus the measure of angle 9 equals the measure of angle ADC. We do need the little m's here because it's an equation. We're talking about their measures, but we're not naming them using the actual degree measure. We're naming them for what they're called, measure of angle 8, etc. Okay, so from there, you're going to try to finish this flowchart proof. Put in your givens. You're going to have, I'll give you a hint here, you're going to have arrows from all three of these and this one into one big box where you're going to substitute. So I'm going to have you try to finish that one. I'm going to pause the video, let you do it, and then come back and check. Okay, so this one had a little trick at the end. Maybe you caught on to it. If not, we're going to talk about it now. Couple of things, just check your work here. Every box gets its own given. I helped you set up this box. We used all four of those to make this equation by substitution. Notice this 14x minus 12 got plugged in where the measure of angle 8 was. That's the substitution, exactly replacing. Be careful that when you write substitution and you write subtraction, don't just write sub. I'm not going to know which one you're using, so be careful that you're writing those out. Your last statement should always be whatever you were trying to prove. So if you stopped here, like our last one stopped at x equals 7, we're not quite done yet. And that's what I mean, this one had a little thing at the end. We're trying to prove the measure of angle ABC is 118. So we actually have to take that x equals 7, and we're going to arrow it over to a new box. And we're plugging that x equals 7 into this given that said measure of angle ABC is 17x minus 1. So those two boxes, we need two more arrows pointing to this new box that substitutes the 7 in where the x goes. Once you substitute it in, you write substitution, and then a new box is measure of angle ABC equals 118. You can just write simplify for that. That's just after you plugged it in, you simplified your math there. So that's what that one should look like. So there's two more proofs here to do. The number 11 has no diagram, but it does have a relationship. So I'm going to have you try this one on your own. Number 12 is a little tricky. So let's do this one together. Okay, so I'm going to do flowchart proof, and I'm looking. I have one given. So measure of angle 4 plus measure of angle 6 equals 180. That's one given. That's it. Well, from that given, there are not a lot of conclusions I can make. So I'm going to have to look at my diagram and see if there's anything else this diagram is telling me. When I look here, I'm noticing I see a linear pair here. Hopefully you see a linear pair here too. I see that 4 and 5 make a linear pair. So I'm going to make a statement out of that. Angle 4 and angle 5 are supplementary because they're a linear pair, right? So I'm going to say linear pair postulate. That's what says that they're supplementary. So if I know 4 and 5 are supplementary, what statement leads directly from that fact? If angle 4 and angle 5 are supplementary, that means measure of angle 4 plus the measure of angle 5 equals 180. That's one of those common combinations we talked about. Stating they're supplementary, then saying they add up to 180 by the definition of supplementary. Well, now I see that 4 plus 5 is 180, and 4 plus 6 is also 180. This is where that other fact that I was pointing out earlier about substitution method comes in handy. If you see that there are two expressions that are equal to the same amount, then you can set the two expressions equal to each other by substitution. So I'm going to take this and this, and I'm going to basically kick out this 180 and replace it with this whole thing. So I'm going to say the measure of angle 4 plus the measure of angle 6 equals, so this whole thing is 180 and this whole thing is 180, so I can say they're equal to each other. Measure of angle 4 plus measure of angle 6 equals the measure of angle 4 plus measure of angle 5, because they're both equal to 180, so that's substitution. Well, what good does that do me? Well, that does me a lot of good because now there's a measure of angle 4 on both sides of the equal sign, and I'm just going to subtract the measure of angle 4 from both sides. So my new equation is going to say measure of angle 6 equals the measure of angle 5. That's just by subtracting the measure of angle 4 from each side. So that's the subtraction property of equality. Now, we're trying to prove that measure of angle 5 equals measure of angle 6. That's what we have here. We have it in a different order, but that's okay. And we're done. Okay, so this video got very long, and I'm sorry about that. I'm going to just cut off the video now. I'm going to pause. I'm going to put the answer to this proof here. Maybe try it on your own first, and then you can check your answer here. Okay, so there is the answer to this proof. Notice the givens go across the top. You had to make this equation here by definition of supplementary. Then you substitute and use your algebra. Okay, thanks.